Have you ever wanted to build your own robot? Can you imagine the thrill of creating a machine with your own hands that can move, react, and even think? Welcome to the awe-inspiring world of DIY robotics, a realm where creativity and technology converge. This isn't just about tinkering with wires and circuits. It's about crafting intelligent machines that can transform our lives in ways we've never dreamed of. From simple line-following robots to complex humanoids, the possibilities are endless. What's exciting about DIY robotics is that it's a hobby that's accessible to everyone. You don't need to be a seasoned engineer or a tech guru to get started. All you need is a dash of curiosity, a sprinkle of patience, and a hearty dose of enthusiasm. Whether you're a novice looking to dip your toes into the tech world or an experienced hobbyist looking to challenge yourself, DIY robotics offers a rewarding and intellectually stimulating experience. Today, you'll learn how to start your journey into the world of DIY robotics. Before you start building a robot, you need to gather the right tools. It's like cooking a meal. You can't start without having all the ingredients ready. So what are these essential ingredients for a DIY robotics project? Let's dive right in. Firstly, a soldering iron is an absolute must. You'll be connecting wires, resistors, and capacitors, and a soldering iron ensures these connections are strong and secure. Remember, a good connection can be the difference between a robot that works and one that doesn't. Next, you'll need a multimeter. This handy tool measures voltage, current, and resistance, allowing you to keep track of your robot's electrical health. It's like a doctor's stethoscope for your robot. Wire cutters are another essential. These are used for cutting and stripping wires. They may seem basic, but trust me, you'll be reaching for them more often than you think. Screwdrivers, both flathead and Phillips, are needed for assembling your robot. Different robots require different types of screws, so it's good to have a variety on hand. A set of pliers can be a lifesaver when you need to tighten or loosen parts. It's also useful for holding small components while you work on them. Next, a breadboard and jumper wires are vital for prototyping your circuits before you solder them permanently. They allow you to test and tweak your design easily. Lastly, don't forget a good quality toolkit. This should include a range of different sized screwdrivers, Allen wrenches, and tweezers for those fiddly bits. Safety is paramount when working with these tools. Always wear protective eyewear, keep your workspace clean, and never leave a hot soldering iron unattended. Remember, the key to a successful DIY robotics project is preparation. The right tools not only make your work easier, but they also ensure the safety and longevity of your robot. With these tools, you are now ready to start your DIY robotics adventure. Starting your first DIY robotics project can feel overwhelming with so many options. But fear not, a simple robot is a great place to start. How about a line-following robot? This project is perfect for beginners. Why, you ask? Well, it's relatively easy to build, yet it introduces you to several fundamental concepts in robotics. You'll learn about sensors as the robot uses them to detect and follow a line. You'll also explore the basics of programming as you'll need to code the robot's actions. And let's not forget about the fun part, designing and assembling the robot itself. This project strikes a fine balance between simplicity and learning. It's not too complex to discourage you, but challenging enough to engage you and give you a taste of what robotics is all about. Remember, the goal here is to learn and have fun, not to build the most complex robot. Now it's time to get your hands dirty and start building your very first robot. A line-following robot is a simple yet intriguing project that is perfect for beginners. This robot uses sensors to follow a line drawn on the floor, and the best part is, you can design the path yourself. Let's break down the process into 3 phases: design and planning, assembly and testing. Phase 1, design and planning. The first step in any project is to conceptualize and plan. For our line-following robot, we need a few essential components. Firstly, a microcontroller board, which serves as the robot's brain. Secondly, infrared sensors to detect the line on the floor. Thirdly, motors to drive the robot. And lastly, a chassis to house all these components. Now let's move on to phase 2, assembly. This is where the real fun begins, as we start putting everything together. Start by connecting the infrared sensors to the microcontroller board. These sensors will detect the line on the floor and send signals to the microcontroller. Next, connect the motors to the microcontroller board. These will receive signals from the microcontroller to move the robot. The number of motors you use will depend on your design. A simple design could have two motors for a two-wheel drive. Once the sensors and motors are connected, it's time to mount everything on the chassis. The chassis provides a stable platform for all the components. Make sure to position the sensors at the front of the robot so they can effectively detect the line. After everything is mounted on the chassis, connect the power source to the microcontroller board. Now your robot is almost ready. But before it can start following lines, we need to program it. Programming a line-following robot involves writing code that tells the robot how to interpret the signals from the sensors and how to control the motors based on these signals. Don't worry if you're not an expert programmer, there are plenty of open-source codes available online that you can use and modify according to your needs. With the design and assembly complete, we move on to the final phase, testing. In the testing phase, draw a line on the floor and place your robot at the start of the line. Power up the robot and watch it follow the line. If the robot is not following the line properly, don't despair. It could be due to several reasons, such as the sensors not being positioned correctly, or there might be an issue with the code. Troubleshooting is a part of the learning process. So don't be disheartened if things don't work perfectly the first time. Remember, building a robot is not just about the final product, it's about the journey. It's about learning new skills, solving problems, and most importantly, having fun. Congratulations, you've built your first robot. Now let's see it in action. Building a robot is one thing, making it work is another. But don't worry, troubleshooting is part of the process. When you're just starting out, you might encounter a few hiccups. Let's talk about some of the common ones. First, wiring mishaps. If your robot doesn't respond or behaves erratically, double-check your wiring. Make sure everything's connected where it should be. Second, software bugs. The code is the brain of your robot, and sometimes even a small error can lead to big problems. If your robot is not behaving as expected, revisit your code. Look for any syntax errors or logical mistakes. Also, remember that your robot's sensors play a crucial role. If they're not calibrated correctly, your robot might not interact with its environment as it should. So fine-tune those sensors. And lastly, power issues. Make sure your robot has enough juice to perform its tasks. A weak battery can lead to unpredictable behavior. Remember, every problem is a learning opportunity. Don't be discouraged if things don't work right away. So there you have it. You've taken your first steps into the exciting world of DIY robotics. It's a journey of discovery, creativity, and innovation. It's about more than just assembling parts. It's about transforming an idea into reality. And that's truly something special. Don't stop here. Continue to explore, learn, and create. There are countless resources out there waiting for you. Online forums, books, video tutorials, and even local clubs and workshops can provide valuable insights and guidance. Remember, safety should always be your priority. Always follow the instructions, wear protective gear, and take necessary precautions when working with tools and electronic components. The joy of DIY robotics lies not just in the end product, but in the process itself. The challenges you'll face, the solutions you'll find, and the skills you'll acquire along the way are all part of the adventure. Keep building, keep learning, and most importantly, have fun. The world of DIY robotics awaits you.